Hello, my name is Meredith Thompson. I'm a research scientist and instructor at the MIT Education Arcade. And today I'm going to talk about our paper, Visualizing the Collaborative Problem-Solving Process in an Immersive Cross-Platform Game. Our overall themes here are that this is a cellular biology game, that we're looking at game-based learning and collaborative problem solving. We do that by analyzing dialogue using a technique called epistemic network analysis. We learn that roles influence dialogue and that the game supports collaborative problem solving. So if one thing we've learned in this past year, it's understanding biology is important. In fact, it's important for just survival. But a lot of people don't understand biology all that much. So if I asked you to imagine a cell, and we asked lots and lots of people to do this, you'd probably, and if you were to draw it, you'd probably draw something like this. You'd draw a circle, you draw a nucleus inside, and then you draw the mitochondria because they're the powerhouse of the cell. Everybody remembers that. And then you draw some other organelles, who knows what else is in there. In fact, that's the reason why we draw that is because a lot of people learn that. They have a typical textbook depiction that is very simple, that everything is neatly spaced and nothing touches. We call this the Whitman sampler view. And the Whitman sampler, everything's kind of evenly laid out and it's all nicely organized and nicely labeled. In fact, cells are very complicated and there's a lot going on. It's dynamic. It's actually a lot more interesting when you really think about what cells do, but most people don't learn that. So what we did was we designed a game called Cellverse, and Cellverse is a virtual reality game. And basically the premise is that there's a patient. You see the patient on the right. The patient has one of 5 classes of cystic fibrosis. We chose cystic fibrosis because it's the first disease to have an FDA-approved gene therapy. And so one of the, and cystic fibrosis is caused by a malformation of a protein. So at different points in the protein synthesis process, the protein can basically not be created appropriately. And each one of those has a different therapy that goes along with it. So if you figure out the class of cystic fibrosis, then you can figure out the therapy for this patient. So you're one of 2 people. You're either the explorer in a VR headset or you're the navigator and you use a tablet and you have to work together to figure out what is wrong with the cell. So again, this is for high school biology audience, but we've done it with people a little bit before and a little bit after high school biology. This is game-based learning, and we have the navigator and the explorer. As you can see on the left-hand side, this is what the navigator sees. There are 5 different classes of cystic fibrosis, and the navigator has a lot of this detailed reference information. And once you figure out which class it is, then you can figure out, see on the right, there are different therapies that you can use. Now, that's what the navigator does. What the explorer does is really, the explorer has a boots on the ground, very, very specific view and can see a lot of the details that the navigator cannot see. So they have to work together to find the class of cystic fibrosis and then to choose the appropriate therapy. Here are 2 people doing the Cellverse. And what I should mention is that a lot of this has been programmed by MIT students. So on the left is Temi. Temi is the explorer, and you can see what Temi's seeing on the screen that's right in the middle of the frame. And Therese is the navigator, and she has the more detailed view on the tablet. We've done this with lots and lots of people, and we've learned a lot about it. One of the things that we're really interested in looking at for this particular study is collaborative problem solving. Collaborative problem solving skills are really important, especially in this day and age. And we've looked at lots of different research, and we've really boiled it down to 4 different categories. First, orienting to the situation. The next is communicating, figure out how you're going to communicate with your partner. The next piece is clue finding. What clues are you going to find in the cell? And finally, you have to select a solution. So our 2 research questions are, how does the game design establish and support the development of interdependence between players? And the second is, how useful is the framework of the collaborative problem-solving process when evaluating players' activity during the game across players who have different levels of background knowledge? So first, let's think about I want to pause and talk a little bit about interdependence. In interdependence, you need both people to solve the problem. And so it's important to be able to balance the roles appropriately. So let's talk about our sample. Our sample is 4 pairs of 8 pairs total. 4 pairs are from this biotechnology workforce program. 3 of them are women, 5 of them are men. We have 2 sets of pairs, 4 women, 2 pairs from high school, and then 2 pairs for men from middle school. Oops. Our procedure for the study is first we get consent, then we have everybody do draw a cell, and we do a short pre-interview. Then we have we tell them the game goal, which is find the type of cystic fibrosis in the cell, so you can help recommend a therapy and cure this patient. We have them play the game, and then we have them do a cell drawing and do a post-interview. So the data we collected are audio and video recordings and pre and post game interviews and cell drawings. What we did was we transcribed and coded those audios and videos, those audio transcriptions, and we used a technique called epistemic network analysis. And I'll talk about that just briefly, so to introduce it to you. Basically, you take a set of utterances, you take everything that somebody said, you put it in one column, and then you have all the codes on this side, and you either code it 1 if the code is in there, or 0 if the code is not. What this allows you to do is to look over and look at frames, see relationships between different codes by not just looking at one line, but looking at a frame. Those frames can allow you to then create a network diagram. Here we see a network diagram, and it basically puts the different codes as nodes on the diagram, and you can basically see relationships between what the different codes that you're studying. You can also look and see the axes. This is two-way communication, moving towards two-way communication. This one's moving a little bit more towards discussing. So those show relationship between codes too. So how does the game design establish and support the development of interdependence between players? Well, one thing we found is roles influence dialogue. And as you can see, explorers tend to do more orienting and one-way communicating, and navigators tend to do more helping, directing, and clue finding. And we actually find that this is a statistically significant difference, where navigators are really helping, directing, and helping find clues, and they're finding clues on the tablet in the reference materials. Explorers are really focused on orienting and exploring the environment. There's two-way communication throughout the entire game, and that means that this is a difficult problem, and difficult enough to be group worthy, which is important in terms of encouraging collaborative problem solving. So speaking of collaborative problem solving, how useful is the framework of the collaborative problem solving process when evaluating players' activity during the game, especially across players with different levels of background knowledge? So one of the things we did was we were curious, what does it look like, the collaborative problem solving process between the older students and the younger students? And when you look at these two network diagrams, it looks very, very similar. I'm going to keep on going because just for sake of time, but feel free to ask me questions. So no statistically significant difference between these two network graphs. One of the things that we did was we found that the clue finding process went through different stages, and so went through different cycles. And so we looked at those cycles and saw patterns, and I'm going to explain some of the patterns. The first 4 cycles of clue finding, stages 1 through 4, we see links between two-way communication and biology terms. We also see that people are getting oriented. In stages 5 through 9, we see links between clue finding, discussing, and biology terms in dialogue in between partners, but everybody's done orienting, so that's kind of gone away. In stages 10 through 17, we find links between clue finding, discussing, and biology terms in dialogue between partners, and it really kind of focuses on that clue finding, discussion, and biology terms. And finally, on stages through 18 through 21, you're really getting to the discussing of biology terms. And so you can see that there are different stages that these groups are going through. So in all, the roles influenced the dialogue topics. The collaborative problem solving process was helpful in understanding these. We saw patterns that really matched the collaborative problem solving process. The patterns of collaboration were similar across groups with different knowledge. And we found that the players cycled through finding, evaluating, and deciding on clues, so much that we could create stages that seemed to match collaborative problem solving process. So this study does have limitations. It's a small sample size, and it is a convenient sample. And we didn't mean for this to be generalizable. We're just really doing exploratory work here. Again, the overall themes here are that it's a cellular biology game. It's game-based learning that we're looking at collaborative problem-solving process. We analyze dialogue using epistemic network analysis. We found that roles influence dialogue and that the game does support collaborative problem-solving. Our next steps are to continue to look at collaborative problem-solving, and spatial knowledge is our next area. And here's our team. And we want to thank you very much. The people who really program this are MIT students, and staff really kind of support them. And so here are the 2019 crew, and on the right hand side is Clever, it's our friend. Clever's non-player character friend. Thank you very much, and I'll be here for questions.